Hey guys, back for another video. So for those of you who are new to the channel, my name is Oscar Savalainen. I do a lot of AI stuff, a lot of coding tutorials and theory, particularly on neural network quantization, because that's something I have a specialty in. It's kind of my current niche in AI. And yeah, today is going to be kind of a short video. We're not actually going to do a follow along coding tutorial like I often do. What we're going to do instead is I'm just going to show a tool that I've been building for a while. I've had this idea for such a long time, and I finally managed to build it out and took some time and built it, and I'm very proud of it. And I wanted to show it off. So yeah, this is just kind of a quick video. I'm just going to try to blast through this and kind of show what the visualization tool does and why it's useful. There's also a Medium post that I wrote if you prefer reading blogs. There's a link in the description. I won't be offended if you click away and just read the blog. There's also a Jupyter notebook, and we're going to be going over the Jupyter notebook today and kind of get an idea for how this thing is and, you know, why is this man saying it's useful? We shall find out. So this is my own personal GitHub, Oscar Savalainen DR. This stands for Deep Render. It's the company I used to work for, and I had my username for them. And so, because I had my own personal account, but then I closed my personal account and I only used this one because this one had way more like commits and contributions. So I was like, I don't want to mess up my Git history. So it's not me being pretentious and being like doctor, it's because it stands for Deep Render, but I will have to change it back eventually, but that's currently what's on my CV, so it's kind of awkward. Anyway, but yeah, this is in a repository called EasyQuant. It's something I've just released, and it's something I've been building for a little while, and it's basically just a little extension to PyTorch's quantization library, just to make some things, as you would imagine, easy. This is where I'm going to be having a lot of these visualization tools, as well as little bits and pieces like quantization modules that, you know, speed up computation, because the ones in PyTorch are not very optimized, and they could be optimized a lot more. So some optimization in terms of training speed and PTQ speed, as well as making them more scalable, so that like you can add all sorts of different PTQ algorithms. You're not limited to observation. You could add AWQ or GPTQ or whatever you want. And then I'm just going to be increasing, this basically falls into the bucket of increasing the number of PTQ algorithms / observers, adding a bunch of unit tests that are kind of good practice to have. So these will kind of be easy to import and use in your own projects. But yeah, well, I mean, it's special for me. Like I've worked hard on this, and I'm proud of the work, but this isn't like rewriting the Declaration of Independence, right? But like it's something I'm proud of. Anyway, today, onto the visualization tool. So what is this visualization tool that this man is yelling about on this YouTube video? Well, it is this. So I'm gonna give a broad overview for what this is and how it works and kind of the little details of these plots. So what this is that firstly, we're laying out the quantization grid of this tensor. So for any arbitrary tensor in your entire network, it can be a weight tensor, it can be an intermediary activation tensor. If you're feeding data through the model, you can hook it into any arbitrary layer, you can capture what's happening, you can see, okay, how does this tensor, this data that we're feeding through the network, how does it interact with the quantization grid of that layer? So all of the gray zone here, this isn't actually a gray zone, it's actually individual lines. But basically there's 256 lines because we're doing int8 quantization, so 2 to the power of 8. And those represent our quantization grid centroids. The red lines represent the floating point limits. So this is a fake quantized neural network. So in this case, this is one of the last layers in a ResNet 18 model, and we're feeding through a picture of a dog. If you've seen any of my other coding tutorials, you'll be very familiar with this handsome little man. Or it might be a girl, actually, I have no idea. This handsome fellow. But yeah, we're feeding that through a ResNet 18 model, and then we're looking at one of the last layers. And specifically, we're looking at activation post-process, which is the requantization step of one of the last layers. And yeah, this blue thing here is the activation data in a histogram form. So, you know, hopefully you know what a histogram is. It's the distribution of data of that entire tensor overlaying with the quantization grid. So you can see how this tensor is interacting with the quantization grid. The red is the minimum and maximum values of this floating point tensor. So this is the absolute minimum value, this is the absolute maximum value. We can see that the absolute maximum value actually goes a bit beyond the quantization grid, so we're actually getting a bit of clamping here. The quantization grid, what comes out of the requantization step is going to be limited to this value. So all of these values between the red line and the end of the gray, they're actually going to get clamped. So And we can actually read off exactly how much of the data is getting clamped. It's, this is not in percentages. So this is, I think, 0.004% of the entire data is getting clamped. Not very much. But yeah, that's what's happening there. And the blue is the distribution of the data. This is the histogram of the activation. Here on the top left, this is kind of zoomed in. So this is the average distribution across all quantization bins. So there's 256 quantization bins in here. This is the average of all of them. And the reason there's 5 lines here is because there's 5 histogram bins per quantization bin. This is a value you could set. You could set this to 20, you could set this to 2, you could set it to 1 and just have 1 histogram bin per quantization bin. But I set it to 5 so we can get some idea of what's happening inside the quantization bin. On average, this is not particularly interesting or, unusual. It's just a uniform distribution. But sometimes you do see particular behavior, like particularly you can see twin tower issues in weight tensors after you've done QAT. If you don't know what a twin tower is, I'll, leave a paper in the description, but it's something that can happen to weight tensors specifically when you're training in quantized space. It's kind of, you see these double peaks, and that has to do because the weight values start aggregating at the quantization bin limits because they don't quite want to be in one quantization bin, but they don't quite want to be in the other one. They want to be in some intermediary value. And so each time they move into one quantization bin, they get rounded all the way to the centroid, and then they kind of want to make their way back to the other side of the quantization boundary and get rounded to the other quantization centroid. So that can be something that happens in weight tensors, but we're not seeing that here. This is also just an activation tensor. But yeah, this is actually a pretty common plot that you see across the literature and quantization. You see the distribution of the data, you see kind of the average into quantization bin behavior. However, the green thing is what I'm actually really proud of. So the green is a Jacobian sensitivity analysis, and what that fundamentally means is that the blue value is the amount of the data per histogram bin, right? That's kind of what a histogram bin is. The green is how much each histogram bin contributed to the final output of our model, which is super cool in my opinion, and this is why I'm proud of this. And so the way a Jacobian sensitivity analysis works is that it's a really cool technique. If you haven't heard about it before, I highly suggest you look it up. It's super, super cool. The idea is that you feed data through your model, like in this case, the picture of a dog, and it gets to the output. Normally, when we're training, we apply some sort of loss to the output and we try to shape it in a certain way so as to manipulate the gradient going back. We don't do any of that in this case. In the case of a Jacobian sensitivity analysis, we take the output, we average it, and we backpropagate it back. We do nothing else in terms of manipulating the loss function. We just backpropagate the entire output, and in that case, what the gradients actually represent is the contribution of each parameter in our model to the final output of that model. And because we can use backward hooks in PyTorch to hook into, any arbitrary layer, we can capture the gradients being fed backwards, and we can actually associate them one by one with the forward data that we captured. So I had to do a bit of coding to make this work. The details are a little bit complicated, but you can absolutely read through the code if you're interested. I have these quant visualization, I have histograms, I have hooks, I have plots. This kind of explains everything that's happening. I go into it in more detail in the Medium post, but this notebook is more just kind of a coding tutorial. But if you do want to read the Medium post, why is it not pushed? Okay, I think I'm not on the main branch. In the main branch, I actually have pushed the link to the post. But yeah, if you just check this out on the main branch and you want to read the Medium post, I would recommend it so you can understand what's happening if you're interested. But yeah, that's the nutshell of what's happening. We have the distribution of the data and how much that data contributed to the final output of our model. So that is it, really. I don't want to spend too much time in this video going through all of the code because I think if you are interested, the Jupyter Notebook kind of does explain everything already. So I will leave a link to the Jupyter Notebook, and I think it explains it in more detail than I could do justice if I was just talking through it. The long story short is we initialize a model, we initialize quant stubs or qconfigs, we assign them, and then we basically add these hooks into our model. We can, and this is just kind of a tutorial on how to use it. You can, add these conditions to which layers you should add hooks and to which layers you should not add hooks, because you don't necessarily want it to add it to all of them. Feeding data through the model, backpropagating, the output, and then just kind of getting an idea for how it all works. You know, this is a function for plotting it for activations, all those plots, and then you can do the same thing for weight tensors, and you can get this kind of thing. Again, I'm not going to explain all of this just because I think the Jupyter Notebook is a better format to explain this than a YouTube video. But yeah, like, and I think this is cool because, like, you can see for the weight tensors as well, you can see this kind of dip in importance around 0, which makes some sort of intuitive sense, right? Like, the values near 0, they might not be contributing as much because they're probably trying to minimize what they're, you know, getting convolved with or like multiplied with. They're actually trying to minimize those values. So it would make sense that the values near 0, they would take a little bit of a dip in terms of importance and how much those weight values contributed to the final output of the model. But yeah, that's it for this notebook. Yeah, so that was it for the notebook, and I think that will be it for the video generally. I don't want to take up your time, I know you're busy. And I will say that, yeah, Medium post, link in the description, link to the GitHub in the description. If you find it useful, please leave a like, and particularly if you find the tool useful, leave a star on the repo. It means a lot, I worked hard on it. And yeah, again, same goes as always. If you have any questions, don't hesitate to reach out. You can leave an issue on the GitHub, you can contact me on LinkedIn, send me an email, whatever. People have been doing that, and I've actually been really, it's been super cool. I haven't been able to give all of those as much attention as I would have liked. Not that there's been like a massive influx or anything, there's been like five people, but I still haven't been able to give those all the attention I wanted. I've just been really, really busy. Started a new job, it's been a whole thing. Like, I've been very, very busy. But yeah, but that, by all means, like, if you do have any questions, please reach out. I know this quantization is kind of difficult, and I struggled when I got into it. And yeah, and I learn new things from new people anyway. So on that sense, I very much encourage you to reach out. Anyway, if you find it useful, whatever, leave a comment. I don't know, you'll figure it out. But yeah, okay, I'll see you guys in the next video. Bye.